All right, so this is the green worksheet from the back. Make sure you have the right thing here. This is still part of 2.1. Does anybody remember what 2.1 started out as? Yeah, me neither. Okay. 2.1 was what we did Tuesday, those crazy graphs. Remember, you just type them in your calculator and then you had to do the analysis? This is part of that same standard. I know it seems weird, but it is. And I'm not going to break them apart into two standards because they're not either one important enough to have a separate grade. So, but this is equation solving. It says a radical equation is equation in which the variable is in a radicand or a radical. To solve a radical equation, you isolate the radical expression, if you can, okay? Then you raise each side of the equation to the power of the index of the radical. So if it was a fourth root, you'd raise each side to the fourth power. Then check for extraneous solutions. Okay, for some reason, can you put your phone away? Thanks. For some reason, extraneous solutions is a really hard thing for students to understand, and they're I don't get it, blah, blah, blah. But extraneous solutions simply mean that if you plug it back in, it doesn't check. Okay. Unfortunately, that can be tricky to do, right? To plug it back in and check it correctly. So we have to be a little bit careful. Now, this is an example that's done for you at the top of the worksheet. Both sides, it had a third degree, a cube root here. So to isolate the radical, they added 1 over to the other side and got 4 right here. Right here. And then they cubed both sides to get rid of the cubed root. So 4 to the third was 64, but when you cubed this side, all you did was get rid of the cubed root. So then they subtracted the 64 over, factored, and got 2 solutions. The trick is sometimes one of these won't check. Now, a cubic, I don't think you'd have so much problem with. But if you end up with something like this, and you end up with, if this was the original equation, and you got a solution of 16 or negative 16, somehow, you can't have the square root of negative 16 because that would be 4i. So there are times when you have to throw away one of the solutions. All right. This one, the solutions were 9 and negative 7. They put the 9 back in, got the cube root of 64, which would be 4. 4 minus 1 is 3. Then they put a negative 7 in very carefully with the parentheses and everything, and they got the same thing. Cube root of 64 is 4 minus 1 is 3. So they both checked. All right. Now, before I do anything else, I want to do 2 things. Do you remember this? That a plus b quantity squared is not a squared plus b squared, yes? Okay. The same way, the square root of 2 plus the square root of 3 squared is not just 2 plus 3. If you were to write that out, square root of 2 plus square root of 3 times square root of 2 plus square root of 3. Please stay with me here. Square root of 2 times square root of 2 would be the square root of 4, which could simplify to 2. When you did your outside and inside arches here, you'd get the square root of 6, because you could multiply those together, plus the square root of 6, which you could add to become 2 square roots of 6. How we doing? Those operations seem okay? And then the last would be square root of 3 times square root of 3, which would be square root of 9, which could become a 3. So then you could add these together, and you get this. So there is no shortcut, guys. That's what I'm trying to tell you here. There's no shortcut. So let's try this one. You don't need to write it down, but square root of x plus 5 times square root of x plus 5. Okay, first times first, square root of x times square root of x would be square root of x squared, or just x. Then outside here, we'd have plus 5 square roots of x. Everybody okay? Right here's another 5 square roots of x. Last term times last term, 5 times 5 would be 25. Okay? We end up with x plus 10 square roots of x plus 25. So did squaring that automatically get rid of the radical? No. Okay? There are times you will have to square things twice today to get rid of the radical. Woo-hoo! So exciting. All right. Yes. Right here, you're adding square root of 6 plus square root of 6. No. You can't. How do I explain that better? It's like, well, if you had 2 root 6 plus 2 root 6, you would get 4 root 6s because it's a multiplication. It's like a 2x plus a 2x just becomes a 4x. So this is like a 1 something plus another 1 something. You can't add what's underneath the radical, okay? If I can think of a better reason to explain that. No, you're not adding what's underneath those. There's just one of these plus another one of these makes 2 of these, okay? Good question. Thank you for asking, because I'd rather you were not confused. Obviously, I don't have a very good explanation. All right. So on this kind, remember it said earlier at the top, always isolate first. So what could I do first? To isolate this radical, I need to get rid of minus 6. So add 6 to both sides. Now, would it matter if this was a negative at this point? Can you take a cube root and get out a negative? Yes. Okay. Yes is the answer to that. You can. You can't take a 4th root or a 2nd root and get a radical, but you can take a 3rd root. Now, what are we going to do to both sides? To get rid of a cubed root, yep, we're going to cube both sides. So the cube root and the cubed will undo each other, and we just end up with an x squared minus 1. And over here, we have a 2 to the 3rd power, which is 8. Use your calculator if you need to. Then we're going to add 1. X squared is 9. If we square root both sides, what do we get? X equals 3 and negative 3. Yes, because we square rooted an x, we got to do the plus or minus thing. Because I could put back in here I don't want to take a lot of time with this, but if I put a 3 in here, it's going to become 9, right, guys? 9 minus 1 is 8. Cube root of 8 is 2. 2 minus 6 is negative 4. If I put a negative 3 isn't when I square it, it's still going to become 9, yes? So I'm not going to take any more time than that. They both work. All right. This is ugly, but it's actually one of the easiest kinds. Because it is one entire radical equal to one entire radical, when we square both sides, the radical just disappears. They cancel out. So we're allowed to square both sides and get 6n minus 3 equals negative 15 plus 7n. I think you could move any one of those. I think I'll subtract that. And then add the 15 over here. I got 12. Did anyone do it and get, anyone else get 12? Okay. Let's check if this works. 6 times 12, I might need you guys calculating. I think that 72 minus 3 would be square root of 69. Is anybody checking? Don't type the square root in, just check 6 times 12 minus 3. Did I do that right? And over here, I have negative 15 plus 7 times 12. Let's see. I think that's 84. Minus 5 would be 79. Minus 10 would be 6. I think they're both 6. square root of 69? Did anybody get them typed in? I think it checks. All right. One more pretty easy one. Anybody? Subtract 8. Good call. Now be careful though. There's still a negative in front of the radical. Equals 8 minus, or 3 minus 8 would be negative 5. Now before we square both sides, you actually probably could square both sides here and it wouldn't matter. But if we divide off that negative 1 that's in front, or change the signs on both sides, we get the square root of x plus 12 equals 5. Then if we square both sides, we get x plus 12 equals 25, subtract 12, and we get 13. If we do 8 minus the square root of 13 plus 12, do we get 3? Well, this would be the square root of 25, which is 5, so we're good. Okay. Anybody lost yet? Good. We're on a roll. Number 4, I'm going to lose altogether. It's just disgusting, and I'll show you why it's disgusting in a second, because we're going to do a little easier version of it. Number 5 is the same kind, because there is 2 radicals and something not in a radical, okay? So on number 5, you can't isolate the radical here. If I move one radical over to the other side, I'm going to have 2 radicals. Let me just show you something. Don't write this down. If I move... Oh, no. What does your number 5 say? Oh. Okay, I have no idea. So can you find this problem somewhere? All right. All right, you cannot, don't write this part down that I'm going to write right here. If you moved this radical over to the other side, does everybody see what I did? I subtracted, so I had both the radicals on the same side, and I tried to square. This is what I would have. Does that look like a good time to try squaring it? Okay, when you did these, you'd get minus 2 square roots of x plus 4 times x minus 3. That's not going anywhere good, okay? That's just a hot mess. So contrary to what it feels like, you don't want them all on one side. You want one on each side. Now, it's still not going to be pretty. So we're going to square both sides. And it's not going to be pretty. This side is going to be okay, right? Squaring a square root, we just get an x minus 3. But over here, you have to, because there's a minus in the middle here, we have to actually FOIL it out. So x plus 4 minus 1 times the quantity, x plus square root of x plus 4 minus 1. All right, we got this one step at a time. So this stays x minus 3. First term times first term. So square root of x times x plus 4 times square root of x plus 4 is just going to become x plus 4. Everybody okay? Because it's x plus 4, quantity squared, so it's just x plus 4. All right. Then the outside arch here is going to be minus 1 square root of x plus 4. What about the inside arch here? Inside terms, another minus 1 square root of x plus 4. And the last term times the last term, negative 1 times negative 1 is plus 1. Okay. In any order you want, we can simplify this. I'm thinking, how about if we subtract an x off each side right away? Would that be okay? So now I have a -3 over here. On this side, I have a 4 plus a 1 would be 5. And how can I combine these? -1 gobbledygooks minus another 1 gobbledygook is a total of 2 gobbledygooks, okay? What's wrong? Oh, okay, yes. I combined these from the same side. Are we okay? But thanks for asking. I'd rather you asked than we're confused. Okay. Guess what, guys? We're halfway there. We just have to do this all over again. It's not going to be as hard this time, I promise. What do we have to do? Any ideas? Think with your Algebra 1 brain. Okay, subtract 5. That gives us -8 equals -2 square roots of x plus 4. Divide by the -2. So we get 4 equals the square root of x plus 4. Now what? Square one more time, square both sides, and this time, like I said, it will be much less painful. We get a 16 over here, and over here we get an x plus 4. So we subtract and get 12, I got. Okay, so let's go back to the beginning and pray that 12 works. The square root of 12 minus 3 should equal the square root of 12 plus 4 minus 1. This is the square root of 9. This is the square root of 16 minus 1, which would give me 3 equals 4 minus 1. Cha-ching. Okay? But guess what? You're only going to get this right on the quiz if I can follow your work. Okay? You actually could graph this and try to find the solution to check yourself. Anybody know what I'm talking about? If we put into y1 the equation square root of x minus 3, and we put into y2 the square root of x plus 4 with a minus 1 out here, you could see where they intersect, and they would intersect at 12, which you'd have to make sure it was even on your screen. It would intersect when x is 12. Okay. Do you have this number 6 somewhere? Okay. This is not as bad as it seems because we have the radical on one side. We are going to have to square both sides, but we're actually pretty darn good at this, right? X minus 5 times x minus 5, we can do pretty fast. At least it doesn't have a radical when we square that side. And this side, the whole thing was in the radical, so squaring it will just get rid of the radical. On the left, I get x squared. Outside is a minus 5x, inside is another minus 5x, and then -5 times -5 is 25. Now, the trick here is that we're going to have to factor and use quadratic of some kind because we have an x squared. Luckily, they factor. So before you can solve by factoring or quadratic formula, it has to equal 0. Remember that business? So can I just do it in one step? Can I subtract the x and the 1 over here? All right, so now I got a 0 over here. What did I end up with over here when you simplify all that? Minus 5x minus another 5x minus that 1x would be 11. Is that right, guys? And then 25 minus 1, or yeah, 25 minus 1 back there is plus 24. That doesn't factor too bad. Factors of 24 that give us 11. 8 and 3. Does that work for everybody? Because you have two negatives multiply to make positive 24, but a negative 8x and a negative 3x give me a negative 11x. You get x equals 8 or 3. These are actually the kind that often don't check. And I think one of these doesn't check. Let me show you what happens. We go back to the very original sentence that said x minus 5 equals the square root of x plus 1. If you put in 8 minus 5 equals the square root of 8 plus 1, you get 3 equals the square root of 9. Does that seem okay? Okay. But if you put a 3 in, 3 minus 5 equals the square root of 3 plus 1. You get negative 2 equals the square root of 4. And this is where students get confused. But when you have a straight up square root of 4, remember, it's just 2. Okay? So negative 2 does not equal the square root of 4. If you had x squared equals 4, then you could put a negative 2 in, but that's not what it says. So this does not check. Whoops. Not check. So we have to say this is an extraneous solution. It is possible to get one where there's no solution. Now, I have a couple more examples. I'm not real sure where they are for you. Before I spend more time though, let me just say this. The assignment is in Delta Math, okay? But, and there's only like, maybe 5 questions. You have to turn in work because I know this is photomathable and you will learn nothing from photomathing this, okay? So for this assignment, you have to include some work. You can't do these without some work. Now, I know you can photomath them and then copy the work down, but you won't do very well on the quiz, okay? So please do the practice. It'll help you if you get stuck. All right, do you have this number 4 anywhere? Okay. Does anybody remember when we have 2 radicals, we want to do what? Can you go back and find one that had 2 radicals and a non-radical? Yeah, we want them on the opposite sides. It means we're likely to have to square things twice, but we want them on opposite sides because we don't want to have to do a square root plus a square root times another square root plus a square root. It's just too messy. So we're going to leave this one, anyway, and move this one over to the other side, if that's okay. You could move either one. Okay, now we're going to square both sides. Which one of those is easy? Left side or right side? Left side, because it's all in the radical, so it all just squares, and the square takes care of the square root, and we get b minus 6. Okay, on the right, it's not too bad, but we are squaring 3 minus the square root of b times, okay. So when we do FOIL here, 3 times 3 is 9. Outside is a negative and a 3 square roots of b. Inside is another negative 3 square roots of b. And then a negative square root of b times a negative square root of b would be what, guys? Positive, and square root of b times square root of b or square root of b squared would just be a plain old b. All right, we are going to have to square this one more time, but it's not going to be hard, I promise. What happens first? Ooh, this could be a little trickier than I thought, I think. It won't be too bad. We can subtract this b off each side. Everybody see that? So we don't have that anymore. Oh, so that just made it easier than I thought. Now what? We're going to combine these, and that'll be a negative 6 square roots of b. Can I move that 9 over to the other side at the same time? Would that be okay with everybody? You can write it twice if you need to, but I got a negative 15 equals negative 6 square roots of b. You could square it now, but it will get messy, I think. What would be a better thing to do? Always think with your Algebra 1 brain. Yeah, divide by -6 before we square that. So we get the square root of b equals, let's see, what goes into both of those? 3 or -3, so we get 5/2. Does that seem right? Negative divided by negative become positive. 15 divided by 3 is 5. 6 divided by 3 is 2. Did I do okay? Okay, so now it's not as tricky as it looks. If we square one more time, what do we get? B equals, square the top and the bottom, and you get 25/4. Everybody okay? Which is like 6.25 if you were to have to type it back in up here. Should we try it? Someone tell me what it was. The left side, hang on. The left side was what? Square root of, was that right? B, which is 25/4, and then minus 6, and that's it? Okay, and then what's the right side say? I just wanted to show you how I check. The left side equaled the right side when I put it in my calculator, right? Okay. So that checked. I think we could be done, or this one is looking a little, do you have this one? Or did we already do this one? I'm so confused. Is it number 6? Okay, so I just need to rearrange these, apparently, these slides, but I apologize. And we don't have to do, you don't have to listen to me do this one. I just think it's one more icky one because when we square this right-hand side, we're going to have a mess, right? If you'd rather just watch, you can, or you can copy down after I'm done. But this left side, when we square it, would just become x plus 6. But the right one, I have 5 minus the square root of x plus 1 times 5 minus the square root of x plus 1. So x plus 6 equals, help me out, 5 times 5 is, okay, and then I have a minus 5 square roots of x plus 1, and in here another minus 5 square roots of x plus 1. And then when I do negative square root of x plus 1 times negative square root of x plus 1, I get a positive, and the radical squared just becomes an x plus 1. We want to combine these. So we get minus 10 square roots of x plus 1. Maybe I won't skip so many steps this time. This 25 plus 1 over here would be a 26 somewhere. And then there was a plus x. Doesn't matter what order we write that in. Okay, I just combined things on that side. So I had 3 different kinds of terms. Okay, then what? Can you finish it up from here? Subtract an x. Subtract the 26. Then divide by that negative 10. Now if I square both sides, I just have what? Anybody get 3? All right, if we go back to the very top, we'd end up with square root of 3 plus 6. equals 5 minus square root of 3 plus 1. So this would be square root of 9 equals 5 minus square root of 4, which is 3 equals 5 minus 2, which works. Okay. I think that's everything that I have for examples. Yes. You can do it on the calculator. It is possible that on the quiz there is going to be an extraneous solution, though. I'm not saying there has to be, but there could very well be one. All right, I'm going to stop the recording, and then I want to just look, because I can't remember how many problems it is in Delta Math.